All right, I'm having a ball with this problem. I was looking at it right after I hung up with you all. Right after I said, okay, I'm going to go look at something else here. Um, I noticed I started doing the problem, and I was going, okay, well, it comes in for landing, all right, and it has a final velocity. Its final velocity, what was its final? Because that's where I was stumped at first. It's 45 meters per second. But I knew they couldn't stump me for long. Final velocity is 45 meters per second when it's here, when it reaches this point here. Okay, the plane is actually 59.7 meters long. So it's got to go through this 25-meter runway. So the total distance that it covers, when the nose is here at an initial velocity, which I don't know, and it's slowing down, and that's the negative velocity there, and it traveled 84.7 meters. So I was like, well, wait a minute. I am stuck. I am stuck for just for a minute. Just for a minute. Because I was going, hold on a second. I don't know the time. Because I don't know the initial velocity. Because look, I know the acceleration is equal to the final velocity minus the initial velocity over time. I've got that. But I don't have these two. So I've got final velocity is equal to the initial velocity. In this case, it's slowing down, so it's minus AT. Okay. Well, I could, I'm wondering if I could do it that way. So I was kind of going all around because I was wanting to avoid that one. If I show you the magic formula, it becomes a very simple problem. Look, what problem is this? 40. Let's use this guy, and we'll come up with the initial velocity. I could use this, and I could say, well, I know that x. I'm still sticking with this. I know that x is equal to v naught, or v final is equal to minus v naught is equal to minus AT. So I know that, well, v final plus AT is equal to v naught. So I can stick that in here for getting the average. So I could go, okay, well, v final plus AT plus v final over t, which I don't know. I love this. This is my time. See what I did? Did that substitution. I didn't know this, but I know this, and I don't know that, but I do know that I'm finding my over 2 times t. Okay? So in other words, I'm saying x is equal to the average velocity times t. And my average velocity, let me make it clearer, is equal to v final plus AT plus v final divided by 2 times, there we go. So I wind up with 2v final plus AT over 2. So I break this up, and I wind up with 2v final. I wind up with v final plus 1/2 AT. All right? So then I know what this is. I go, oh wait, well, x is equal to v final plus 1/2 AT times t. Aha! That's where we get x equals v final t plus 1/2 AT squared. I knew I wouldn't have to use that because look, v final t plus 1/2 AT squared. All right? There we go. See, in this case, we got the smaller velocity, but we're still doing it plus the time. Is equal to 84.7. So what do you wind up when you do that? So I've got 84.7 meters is equal to, what did they say the initial final velocity was? 45t plus 1/2 times, what's it, 5.7, which has become positive now, times t squared. I've got an ugly quadratic on my hands, that's all, but I can find the time. Now, if you wanted to, you could have jumped right in and said, all right, well, v final squared is equal to v naught squared minus 2a, because it's slowing down, times x final, which is 84.7 minus 0. Okay, and you could have found v final squared plus 2a times 84.7 is equal to v naught squared. And then jumped right in and said, okay, so you solve for v naught squared, all right, and then you go, all right, then x, then the time it took, x is equal to the average velocity times the time, x over that average velocity is equal to the time that it took for the plane to clear. Couple ways to do that. I know that was ugly. Is that the type of problem to be on a test? Are you kidding me? Not in a million years. Let's talk about free